as well, instead of typing all of this in, and it'll come up. Some of you are probably in there from the first test. So we're going to go through all the material, and you should work through questions in the booklet first. And then once you think you have, memorized everything you need to memorize, you can typically get a formula sheet. That's the formula sheet you're going to get for your exam. Usually gets posted on OWL right around now, right around the week before. So you can print that out and just use that as your formula sheet for your exam. And do as many practice exams as you possibly can, okay? So do the booklet first, and then once you think you're more confident, you know what you're doing, then tackle an exam. Treat the exams like the real thing. Don't print the answers and have them, right beside you, because then you get a false sense of what you know. So just treat it like a real exam and then mark it afterwards, and hopefully you'll get better as you do more and more exams, okay? And in addition to the exams I gave you, usually they will post a couple of question sets or exams on OWL. So hopefully they'll post some that aren't in the ones I've given you, so you have even more practice. So we'll take breaks today around 10 or quarter after 1, and then close to 2:30ish. And so you can take a break to get food and drinks. So don't worry about that. So in the front, you've got your table of contents with everything we're going to cover today. So we're going to start with the exponential. So if you flip through all the formulas and everything, it goes to page 10. So flip to page 10. So exponential distribution, we talked about the Poisson back at the last test, where you had, so many hits on a website per minute, things like that. So many people walk through the library door per minute, things like that. The exponential distribution describes the waiting time between the Poisson occurrences. So here we have your f of x is lambda e to the negative lambda x. That's our function. The mean and the standard deviation are both 1 over lambda for the exponential. And the formulas that you need, usually lately he gives you all 3 of them. Before, sometimes you only get 1 formula, but the last few years, students have been given all 3 of the formulas. So if we're looking at a greater than or equal to some number, then we do e to the negative lambda a. If it's less than or equal to some number, then it's 1 minus e to the negative lambda a. And if it's between a and b, it's e to the negative lambda a minus e to the negative lambda b. So in terms of examples, if jobs are sent to a printer at an average of 3 jobs per hour, example 1 here, then the rate, something per something, that's our lambda. That's a rate. And so if they ask you what's the expected time between the jobs, that's your mean, or your E of x. And that's 1 over your lambda. So this would be 1/3 or 0.33 hours. Have your calculator handy that you're going to use for your exam, because we're going to do lots of calculations, okay? Okay, so now instead of asking, what's the probability of so many people, or so many jobs in this case, per unit of time, it's what is the probability the next job is sent within a certain time period. So within 10 minutes, so that's less or equal 10 minutes. So we need the less than formula. Remember, whether it's less than equal or less than doesn't matter, because it's a continuous graph, so there's no area equal to the number anyway. So if we have x less or equals c, we have 1 minus e to the negative lambda c. And 10 minutes over 60 minutes is 1/6 of an hour. So I'm going to convert that to hours because I have jobs per hour in the question. Okay, jobs per hour. So probability x less or equal to 1/6, 1 minus e to the negative, lambda is 3, and this c is 1/6. So it ends up being e to the negative 0.5, a half. So get your calculator out. You should have an E button on your calculator. Some people have to hit the negative 0.5 and then the E button. Some people have to put the E button first and then that, and then do 1 minus that answer. So take a minute and see if you can get it. It should be 0.393. So see if you can get that. As you have questions as we go through today, just type them into the Q&A, the question and answer, and I'll see them pop up and then I can answer your questions, okay? Okay, exponential random variables sometimes give good models for the time to failure of mechanical devices. For example, we may want to measure the number of miles traveled by a given car before its transmission ceases to function. Suppose this distribution follows an exponential with mean. So this is the mean. It's not a rate, it's just miles. So that's mu. So mu equals 100,000. Okay, what is the probability a car's transmission will fail during its first 70,000 miles? Okay, so if mu is 1 over lambda, then lambda is 1 over mu. They're 1 over each other. So we can do 1 over 100,000 and get 0.00001. And that's our lambda. And again, we're doing within the first, so that's 1 minus e to the negative lambda c. So 1 minus e to the negative lambda times c, which is 70,000 miles. And 70,000 times negative 0.00001 is e to the negative 0.7. So type this in, it should be 1 minus 0.497 or 0.503. Okay. So students arrive at Weldon at a rate of 3 per hour. So rate, so many per hour. So write down what letter that is. Can I go back to this example? Yeah. So for everyone else who's moved on, write down your lambda. So lambda is a rate. So lambda equals 3 per hour. And what is the probability it'll be more than 10 minutes before the next person arrives? So more than 10, we're looking at a greater than. So then for the greater than, we don't have the 1 minus in it. And we did 10 minutes over 60 earlier, so that'd be 1/6 of an hour. So go ahead and fill it in and see what you get here. So this would be probability x greater than 1/6, e to the negative 3 times 1/6, e to the negative 0.5. Should have given you 0.607. Okay, what is the probability time between arrivals is between 10 and 20 minutes? So 10 we said was 1/6 of an hour. So 20 over 60 would be 1/3 of an hour. So write down what you think it will be. Your formula is between A and B is e to the negative lambda A minus e to the negative lambda B. So this would be e to the negative 1/6 times lambda. So that would be, lambda was 3, so negative 3/6 minus e to the negative lambda times b. So that'd be negative 1/2, and that'd be negative 1. And you should get 0.234. Okay, the memory list property. Suppose you're waiting for the bus to arrive, and you know that the time in minutes until the bus arrives follows an exponential with lambda equals 0.1. The expected time until the bus arrives is 1 over lambda, which equals 1 over 0.1, which is 10 minutes. Now, suppose you've already been waiting at the bus stop for 2 minutes. Your expected wait time is still 10 minutes, okay? The exponential distribution has no memory that you've already been waiting. So when you do a question where you have probability x is greater than a plus b, given x is greater than a, the answer will just be x greater than b. So I'll show you an example of this. So the time required to repair a machine is an exponential random variable with rate 0.5 downs per hour is our lambda. So lambda equals 0.5. What is the probability that a repair exceeds 2 hours? Okay, so write your answer for A, exceeds 2 hours. So we have probability x greater than c equals e to negative lambda c. So x greater than 2 is e to the negative 1/2 times 2. Now, what is the probability that the repair time will take at least 4 hours given the repairman has been working on the machine for 3 hours? So that's greater than 4 given greater than 3. So if you look back here, we want greater than 4 given greater than 3. So A is 3 here, and B, well, 3 plus 1. B has to be 1. And so this would just be the probability x is greater than 1. So you can memorize this formula, okay? Or you can draw it out. I kind of draw it out sort of like a number line to see it. So either one will get you the answer. So if we go from 0 to 4 and put 3 there. So basically it doesn't remember that it's already been 3 hours. So we want at least 4 hours, which means at least 1 more hour. So probability x greater than 1 is e to the negative lambda times 1. Okay, any questions? Okay. Calls arrive at an average rate of 12 per hour. Find the probability a call will occur in the next 5 minutes, given that you've already waited 10 minutes for a call. Okay, so go ahead, tell me what your answer is here. So this one says, find the probability a call will occur in the next 5 minutes, given you've already waited 10 minutes. So you're already here, but it says occurs in the next 5 minutes. So you just have to find in the next 5 minutes. You don't have to worry about the given that you've already waited 10 minutes. Now it's not greater than, given a greater than this time, because it says occur in the next 5 minutes. So it doesn't say more than something given more than something. So this one's a little different. So our lambda here is 12 per hour. 5 minutes out of 60 minutes would be 1/12 of an hour. So probability occurs in the next 5 minutes would be that x is less than or equal to 1/12. So this would be 1 minus e to the negative lambda times 1/12, which would be e to the negative 1. Okay, so now we're going to do the question that is the trickiest one I've seen for a test. So suppose there is a 65% probability that the time between calls is less than t hours. What is the value of t? So 65% probability that the time between calls is less than t hours. So we have probability x less than t hours is 65%. That's what they tell us in the question. The less than formula is the 1 minus. So 1 minus e to the negative lambda a equals 0.65. Now we have to solve this. We know the lambda, so we can put the lambda in. 1 minus e to the negative 12a. So substitute lambda. But now we have to figure out how to solve this for a. So what we do, we can bring the e over here to make it positive. And then we can have 1 minus 0.65. 1 minus 0.65 is 0.35. And gosh, so back to grade 12, I guess, right? How would you solve an exponential equation that looks like this? I suppose if you took 1225 in first year, you would have seen this. But if you took 1228 and 1229, then you may not have seen this for a few years. This would be that we would take the ln of both sides to get rid of the e. So we have ln 0.35 equals ln e to the negative 12a. And then because it's a ln, you can bring the exponent down in front now. Ln of e is 1. So now get out your calculator, type in ln 0.35 divided by negative 12. Ln 0.35 divided by negative 12. And you should get an a value So 0.087485, etc. And then that's per hour, that's hours. So if we times by 60 minutes, then we can say how many minutes. 25 minutes. If you don't keep all the decimals, it's 5.22. So it just depends on how many decimals, but I think I kept them all there. And it was 5.25. So still approximately 5 minutes. Okay, any questions with the exponential? Okay, so now we move on to the uniform and then the normal distribution and then the normal approximation. Now the normal and the uniform were on your first test. So we can just do a couple of examples of the uniform and a couple of examples of the normal because that was already tested. So turn to, so continuous random variables starts on page 19. So continuous random variables can take on any possible value. So we're looking at graphs like the uniform is a rectangle where the area is length times width. We can have the normal where you have the table to look up all the values. You can also have a triangle. Area is base times height divided by 2. And remember that the probability of x equaling a number is 0 because you have to have an area. So it has to be between two numbers to be able to calculate an area. And keep in mind that the total area is always 1. So something like this would have an equation x over 50. That would be a triangle. Something like this would have an equation f of x is 1 over 50. So no x. Now, if you have a graph of a uniform, and let's say it goes from 1 to 15 here, then that would be 14 units along the bottom. So that would mean that the length is 14, then the width has to be 1 over 14. And that would be to be able to make the length times width equal to 1. Okay, so keep that in mind. So this equation would be f of x equals 1/14. The whole area of the triangle, the rectangle, and the normal have to be 1. So the total area is always 1 for any uniform graph. So whatever the shape is, the total of all the shape or shapes, if there's more than one, has to add up to 1. Okay, so they'll tell you on your formula sheet the mean and the standard deviation of the uniforms. The mean is a plus b over 2. The standard deviation is b minus a over root 12. So those are always given to you on the formula sheet if you need them. So here we have f of x equals 1/10 for 5 to 15. So there's no x here, so therefore it's a uniform graph, which means it's a rectangle. And that means that y is always 1/10 for every x value. It tells you that x goes between 5 and 15, and then it's asking for the weight between 12 and 15. So we can kind of shade our area there between 12 and 15. Area would be length times width. From 12 over to 15 would be 3, and this would be 1/10. So it would be 0.3. Okay, so let's do one where you have to draw your own equation. So flip over a page to example 4 here. So continuous random variable x has probability density function f of x equals x over 2 from 0 to 2. Find the probability x is greater than 1. So let's make a table of values to make a sketch. This is f of x equals x over 2. So it tells us that x should go between 0 and 2. So let's put in 0, 1, 2 and see what we get. So if we put 0 into here for x, we get 0 divided by 2 would be 0. If we put 1 in for x, 1 divided by 2 would be a half. And if we put 2 in for x, 2 divided by 2 would be 1. So over 1 over 2, this is our 0. So 0, 0, over 1 up a half, over 2 up 1. So there's our graph. It's just a quick sketch, right? X, f of x. And we want x to be greater than 1. So we want kind of this in here. That's the area that we want to find. Okay, so lots of ways to do it. I could split it into a triangle and a rectangle and add up the two areas. I could also do this area in here, do less than 1 and then subtract from 1. That's probably what more people would prefer. So the area greater than 1 is 1 minus the area less than 1. So it's a triangle that I'm subtracting. So base times height divided by 2. Base is 1, height is 1/2. So that would be 1 minus a quarter or 3/4. 0.75 as a decimal. Okay, this one you have to find the equation. So you have to find the c in the equation yourself. So f of x equals cx for 0 to 6. So I'm going to do 0, 3, and 6. So if we put 0 in here, 0 for x, c times 0 would be 0. Put 3 in for x, c times 3 would be 3c. Put 6 in, c times 6 would be 6c. So we make a quick sketch. So 0, 0 over 3 up to 3c. And over to 6 up to 6c. And we're trying to find c this time, but what we do know is that all of this area has to add up to 1. So we can use that fact to be able to find what we're looking for here. So this whole shape, well, it's a triangle, so base times height divided by 2 has to add up to 1. The base here is 6. The height is 6c, so 6 times 6c over 2 has to add up to 1. So that 6 times 6 is 36, divided by 2 is 18. So c is 1 over 18. Okay, now we'll do one that involves a little bit of algebra. So we'll do a couple more of these and then we'll get on to the normal. Okay. So let random variable x be uniformly distributed on 0b, where the mean equals the variance. What is the value of b? Okay, so this is a and b, so a is 0. We know that the mean equals the variance. So if I flip back to show you the equation, there was the mean and the standard deviation. So the variance would be the standard deviation squared. Okay, the variance would be the standard deviation squared. So we know that mean equals variance. So a plus b over 2 is b minus a over root 12 squared, sigma squared. So those formulas would be given to you. Now you know A is 0, so you can substitute all the A's to be 0. So this would just be B over 2 equals B over root 12 squared. So if we square B over root 12, we get B squared over root 12 squared is 12. And then we would cross multiply. So this way we would get 12B equals, this way we would get 2B squared. So we can bring it all to one side and then factor. So if we take out a 2B, we would have B minus 6. This would mean B is 0, and this would mean B is 6. B can't be 0 because then we wouldn't have a rectangle, right? We would just have the point 0, 0. So if A is already 0 and B is 6, that would give us a rectangle. But if A was 0 and B is 0, we wouldn't get a rectangle. Okay, suppose the time between two buses is uniformly distributed between 0 and 15 minutes. What is the probability we'll wait at least 10 minutes for the next bus? So uniformly is a rectangle. So 0 and 15, so that's 15 minutes. So what's our height here then, or our width? If this length is 15, then our width has to be something to make the area equal to 1, right? So if this is 15, this has to be 1 over 15. And they want you to wait at least 10 minutes. So they want you to find this area in here. So the area is length times width. From 10 to 15 is 5 times the width of the rectangle is 1/15. So 0.33 repeat. Okay. Probability distribution function of random variables given by the following density curve, find the value of A. So what we know is that if we split it up into different shapes, we know that area 1 plus area 2 has to be 1. So area 1 is base times height over 2, and area 2 is a length times the width. So what's the base? The base here is 2, and the height is 1/2 A. So 2 times 1/2 A over 2. Base times height. Base is 2, height 1/2 A over 2. Plus length times width, 6 times 1/2 A. So these twos will cancel. And 1/2 of 6 is 3A. So we have 3 plus 1/2. So 3 over 1 plus 1/2 is like 6 over 2 plus 1 over 2 is 7 over 2. So 7 over 2A equals 1. 7A equals 2. A is 2/7. Here I just cross multiplied. Or if you prefer, you can think of just multiplying both sides by 2 at that point. Okay, a particular 1.5 volt battery has a voltage with uniform distribution between 1.4 and 1.6 volts. So 1.4, 1.6. What is the expected value of the voltage? So the expected value for uniform is A plus B over 2. So that'd be 1.4 plus 1.6 over 2. Should be 1.5. if the box contains 120 batteries, what is the expected number with a voltage more than 1.5 volts? So I drew down here for you that between 1.4 and 1.6 is 0.2. So this is 1 over 0.2, which would be 5. So that's the length and width. So here, if we want the probability greater than 1.5, it would be length times width. The length between 1.5 and 1.6 is 0.1 times 5, which is 0.5. So the expected number is 0.5 times 60 batteries. So we have to multiply by how many there are. Oh, times 120 batteries, sorry, which would be 60. So take your probability and multiply by your N, or your number of batteries, and that would be how many would be voltage more than 1.5 volts. Okay, so next is the normal distribution. So we covered that for test 1. So you've already been tested on it, but they said that they would test you on all of chapter 6. So we'll review it a little bit here. And so, oh, maybe we'll do these examples too, just in case. Back to example. Yeah, I can go back to something later. Okay, let's do this. Just 2 more examples and then we'll do the normal. Suppose that a random variable follows a uniform distribution on -2, 8. What is the lower quartile? This one's a bit tricky. So from -2 up to 8. So that's a total of 10 units. So we know the lower quartile is like the 25th percentile. So let's take 0.25 times 10, and that would be 2.5 units. So we know that it's 2.5 units from -2. So if we move over 1, 2.5 units, then the lower quartile would be at 0.5. Okay, so let's go through that again. First, graph it to see how many units it is total along the rectangle, which is 10. 25th percentile, or the lower quartile, is 0.25 times n, so 0.25 times 10. So we need 2.5 units from the lowest number, and so go up 2.5 from -2. In other words, -2 plus 2.5. This is for a uniform graph, so this isn't like following the quartile rules for anything like other than, it's just the basic uniform graph. So we're not rounding anything. Okay, this one, we have uniform on -2, 8. What is the probability that x is greater than 0 given x is less than 4? Greater than 0 given x less than 4. So A given B, your given formula from test 1, A given B, would be A and B all over B. So A and B over B. So greater than 0 and less than 4. So if we think about the graph here, So greater than 0 and less than 4. So 4 is here. Greater than 0 and less than 4 would be in here. Now, you know that the length is 10, so the width here has to be 1/10. So the area that would be the probability here, greater than 0 and less than 4, would be length times width, which would be 4 times 1/10. The total area less than 4 would be all of this. And that would be 4 plus 2 is 6 times 1/10. And technically the 1/10s just cancel out, so we get 4 over 6, or 2/3. Okay, so now we'll go on to the normal. So I guess I'll do one on the empirical rule just in case. Okay, so the normal starts on page 29. So you guys should get your normal tables out that you've been working with all through the course. Have those handy, either if you have a printout of them or the textbook or whatever you've been using all along. You can flip back and forth in the book, but that's sort of annoying. It's on page 201 and 202. So we know the empirical rule says these three percentages, 68, 95, 99.7. So within one standard deviation, either side of the mean is 68%. Within two standard deviations, either side of the mean is 95%. And within three standard deviations, either side of the mean is 99.7%. So the empirical rule, so normal distribution has mean of 10, standard deviation of 2. Find the probability that it lies between 8 and 14 using the empirical rule. So the mean is 10, so we go up and down by 2s. So we go down by 2 from 10 would be 8, and up 2 from 10 would be 12. That would be 68%. If we go down another 2 and up another 2, then that would be 95%. Okay, and we go up and down by the standard deviations. Now the question asks for between 8 and 14. So I don't need to do the third standard deviation because I already have 8 on my graph and I already have 14 on my graph. So there's the picture of the shading that we want. So now there's percentages that you can memorize if you want, one page back, if you want to memorize each percentage in between each of these, or you can just memorize the 68, 95, 99.7 and then just work it out from there. So for instance, from the green line to the green line is 68%. So that means from the middle to the green line is half of 68, or 34%. So that's the shading on the left. 68 divided by 2. On the right, well, from pink to pink line is 95%. So from the middle to the pink line is half of 95, or 47.5. And then my total is just to add them both up. Okay, so in terms of Z, I'm sure everyone knows how to look up values on the Z table. So let's just do one with absolute value. And then when we use Z, later we can do the normal approximation, and we'll be looking up the Z in that as well, kind of in the last step. Okay. So this is on page 33. So probability absolute value z is greater than 1.25. So absolute value z, we have to plot the plus and the minus of the number. So we plot negative 1.25 and positive 1.25. But we have to decide which is the shading. Is the shading the outside two areas or the in between them? Depends whether it's less than or greater than. Pick a number. If you pick 0, put 0 in here. 0 greater than 1.25. Well, 0 is not greater than 1.25. So that means 0 is not being shaded. And that means it's the outside two spots. So then we can just look up the area below negative 1.25 and double it because it's symmetrical. So negative 1.2, 0, 1, 2, 3, 4, 5. So there's the area below negative 1.25, 0.1056. So that's the area on both sides. I'll just give you a minute to make a sketch because you don't have the sketch in your notes if you're drawing your own notes. Okay, so this area would be 2 times 0.1056, 0.2112. Okay. So part B says probability absolute value of z is less than 0.9. So we plot 0.9 and negative 0.9. Again, if we test a point, 0 less than 0.9, that's true. So the shading we want this time is in between them. So go ahead, write down what you think the answer would be here. So we can either look up the area on both sides, well, one side and double it and subtract from 1, or you can do z less than positive 0.9 minus z less than negative 0.9. So either of those methods will work. So 0.9 on our z table works out to 0.8159. That's the area below 0.9, 0.8159. And then below negative 0.9 is 0.1841. It works out to 0.6318. Okay, so that's practice with the actual Z table. Now you have to practice obviously converting. So a real life question would have not a mean of 0 and a standard deviation of 1, which is what the table has, mean of 0, standard deviation of 1. And so you have to be able to convert with the Z formula. Okay, so flip to examples of that on page 37. Okay, so the Z formula is Z equals X minus the mean all over the sigma. So if we want X greater than 90 here, we've got normal random variable, that means it's a Z question. We've got the mean is 100, we've got the standard deviation is 10. So we need probability Z greater than. If X is greater than, then Z is greater than. Take the X value, which is 90, minus the mean, which is 100, all over the sigma, which is 10. So that's Z greater than 90 minus 100 is negative 10 divided by 10 is negative 1. And so we're looking at greater than would be this way. So we would look up the area below negative 1 in here. So on your table, below negative 1 would be 0.1587, 0.1587. So this would be 1 minus 0.1587. And that would give us 0.8413. Excuse me. Okay, so let's do an example where you have to work backwards as well. So we'll do part A and B of example 4 here. So at the bottom of page 38. So we've got mean 100.4, standard deviation 11.6, normal distribution, so we know it's Z. What is the probability the child's IQ is greater than 125? Okay, go ahead, use your formula, work that out for me. See what you get. Okay, let's see what you got here, guys. So we've got probability X greater than 125 is probability Z greater than 125 minus the mean, 100.4, all over the sigma, 11.6. So that's probability Z greater than 2.12. So we look up 2.12 on the table, 2.1101112. We get 0.983. That would be the area below 2.12. 0.983, that's the area below. We want the area above, so we have to do 1 minus 0.983. So 0.017 or 1.7%. Okay, any questions about that one? Okay, so for part B, I'm just going to write down what the mean and standard deviation were. So now the backwards kind of question, which they like to ask on the test, about 90% of children have IQs greater than what value? Okay, so 90% of children have IQs greater than what value? So draw where you think the 90% would go. Draw a little Z curve. And where do you think the 90% goes? So about 90% of the children have IQs greater than what value? Okay, so if 90% of kids have an IQ greater than this value, then the value has to be a very low IQ. And that means 10% is here. So this is an area that we have. We have the area, right? We don't have the Z to look up. Z is 1.5. We have the area, what it equals. We want to know what Z equals this area. So we have to look up area in the body of the table. So 0.1 is on the negative chart. Anything below a half will be on the negative table. And we have to look up 0.1. So we've got 0.1003. So that corresponds to negative 1.2, and then across the top is 0.8. So this 0.1, the closest to 0.1 here, corresponds to negative 1.28. So then we have to put that into the formula to solve. So Z equals X minus the mean all over the sigma. And remember to solve, we just cross multiply and add 100.4. And it's about 85.6. And keep in mind, sometimes they'll put numbers all over the place, like, 73, 85, 95, etc. Sometimes they put them all in a row, 84, 85, 86, 87. So if they put them all in a row, you'll have to look at what the percentage says. Sometimes they'll say at least 90% of kids have to have an IQ greater than something. So just make sure you make the percentage work out on your graph. Sometimes you have to round up or down and not follow rounding rules. So 85.6, we would, mostly round up, obviously with our regular rounding rules. But, if we needed to have, let's say that rounds to here, and if we need to have at least 90% above, then we would round down, even though it's 85.6, to have the at least 90. So you just have to look at how it's worded on your exam. And you'll see that in the practice. Okay, so let's do one more. And after this one, we'll take a break before we do the normal approximation. Okay, suppose grades are normally distributed with a mean 65, variance of 9, so sigma is 3. Find a tolerance interval within which 90% of the test scores lie. So tolerance interval means in the middle, there's 90%, which means there's a total of 10% on the sides or 5% on each side. So what we can do is find these numbers. Now it's all symmetrical, so once you find this number, this will just be the positive. So look in the negative table for the area 0.05. So in here, and 0.05 lies between two values, between negative 1.64 and negative 1.65. So we call the middle, because it's exactly in the middle, negative 1.645. This one will be positive 1.645. And then we put them into the formula. So negative 1.645 is the first X minus the mean, which is 65, all over the sigma, which is 3. Cross multiply, add 65, and you get 60.1. So go ahead and do the other one. Positive 1.645 equals x2. Fill it in and tell me what's x2. And then we have our interval. Okay, so this is minus the mean, 65, all over the sigma, which is 3. Cross multiply, add 65, and you should get 69.9. And that would be your interval. Okay, so let's take a break before we start the next section. So come back at, we got like 15 minutes, so 1:20.